Hello, welcome to a video on section 14.1, which is about graphs of sine, cosine, and tangent functions. So in this section, we will now graph the trigonometric functions that we have talked about in chapter 13. And this will represent the last functions we'll graph for the school year. We will do a little bit more graphing in 14.2, where we'll move the graphs from left to right, up, down, or flip them over, which is called reflection. But after sine, cosine, tangent graphs, we have no more graphs for the rest of the year. Okay, so here we have three equations. And we have a bunch of letters. A, B, H, and K. So I'm going to talk about what each of these letters represent, and then when we do the graphs, you'll see why those letters represent those things. A is going to represent the amplitude. It's kind of like the vertical stretch, which we talked about with some other functions earlier in the year. Now the B helps determine the period. The period is basically going to be the length of one cycle. Now, for sine and cosine graphs, the period will be determined by 2 pi over b. And we'll see why that's the case in a little bit. And it will equal pi over b for tangent graphs. The period again represents the length of one cycle. I know I already wrote that, but I'll write again. The H represents a horizontal shift, which we've always seen from previous graphs. For trig graphs, it's also called a phase shift. And K represents a vertical shift. So we kind of familiar with A, H, and K. B is going to be kind of new. It helps determine the period, which is the length of one cycle. And you'll understand what's one cycle, what I mean by one cycle when I do the graph. Okay, so we're only going to do 3 examples in this video. We'll do example 1, then 5, and 6. The other examples and the rest of the notes we'll actually complete when we meet as a class. So let's look at example 1. You're asked to graph y equals sine x. Well, like with most graphs we've never done before, it probably makes sense to make a table. And also it probably would make sense to draw a makeshift unit circle so that we know our graph looks somewhat accurate. And if you remember, that's at 0 radians. That's at pi over 2 radians. That's at pi. That's at 3 pi over 2. And of course we get back to 2 pi radians when we go around the circle. And if you remember the coordinates are 1, 0, and of course 0, 1, negative 1, 0, 0, 1. Now x, in this case, I probably should have used theta, but it's like theta. It'll represent the angle. So, if you think about it, when our angle is 0 radians, and by the way, graphs of trig functions are usually done in radians. Because if you use degrees, you're going to have some really large numbers. So they're usually done in radians. So for example, when I have 0 radians, the sine of 0, if we look at the unit circle, because we want to look at the y-coordinate when using the unit circle, is 0. So I'm going to have 0, comma 0 as one of my points. I'm also going to try all the other x-coordinates. Try the other angle measures. Pi over 2, pi, 3 pi over 2, and 2 pi. So what this implies is that I'm going to use the remaining y-coordinates of all the points I labeled on the unit circle. So again, the sine of 0 radians is 0, as we've learned from unit circle. The sine of pi over 2 radians will be 1. The sine of pi radians will be 0. The sine of 3 pi over 2 radians will be negative 1. And the sine of 2 pi radians will be back to 0. So when I label this appropriately, we'll call this pi over 2, which is about 1.5. Call that pi. We'll call that 3 pi over 2, and we'll call that 2 pi. We'll call this 1, and we'll call this negative 1. So when I label my points, or plot my points, I have this. When I draw the curve will look like this. Now another way to think about it, it's almost like you're unraveling the unit circle, because what I'm doing is I'm starting at this location. I'm going around the unit circle once, and I'm labeling or plotting all the points based upon what I see from the unit circle. I'll show you a better demonstration on the iPad when we meet again as a class. But that will be a sine graph. If you were to actually go backwards, so if I were to go in the clockwise direction, so at negative pi over 2, which is equivalent to 3 pi over 2 because they're coterminal, I'm going to have the same y value as I got at 3 pi over 2. Then at negative pi, we'll be back at 0. Negative 3 pi over 2 will be at 1. And of course at negative 2 pi, back down to 0. So it's just a wave, if we think about it. Now, our a value here was 1. Our b value was 1. Our h was 0. And our k was 0. So this right here is considered to be the parent function for sine. That's what we have right here, the parent function. And because a stands for the amplitude, what it really represents in a way, it's kind of like the height of the graph. So basically, it's from middle to peak. That's what we consider to be the amplitude. And by the way, the middle of the graph, if I were to draw a dashed line through it, is called the midline. This will be pretty important when we get to 14.2. And the length of one cycle, if I highlight this, the length of one cycle that's considered one cycle because it repeats itself afterwards or beforehand. is 2 pi radians, because after one cycle, it starts repeating itself, as we see from the unit circle. And that was the formula we had up here. 2 pi over b helps determine the period. Because our b is 1, we see our period as 2 pi. So that's basically example number 1. That's how we do a sine function. Let's skip down to number 5 for cosine and repeat the same process. So we have x and we have y. We're going to use the same x coordinates as before. So, again, think about unit circle. So you have 1, 0, 0, 1, negative 1, 0, 0, negative 1. So, oh, geez, I can't believe I just did that. That was dumb. We need to look at the x-coordinates because we're dealing with cosine. My apologies. So, when we're at sine of 0 radians, cosine of 0 radians, we have 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is back to 0. And cosine of 2 pi is back to 1. Okay, so that's at pi over 2, pi, 3 pi over 2, and 2 pi, and 0. So the way the cosine graph will look, we're going to plot the first point right here, then there, here, here, and here. And if you were to keep going, it would just repeat itself. Again, one cycle for cosine is still going to be 2 pi. That's still a length of one cycle. The amplitude is still going to be 1. Basically from peak to middle, the amplitude is still 1. And remember, our A, B, H, K values were the same as they were in example number 1. And so this is the parent function for cosine graphs. So we'll investigate this more when we meet again as a class, and we'll start making some changes to it. Another thing you should notice between cosine and sine is that the sine starts at 0, 0 and goes up, then down, then back up again. The cosine will start at 0, 1, goes down, then back up. And that's, if you think about the unit circle, the x-coordinate is cosine because it decreases as you're going counterclockwise. And after you get to pi radians, it starts increasing afterwards. Whereas for sine, it's because of this y-coordinate, it's increasing, then decreasing, then still decreasing, then increasing when we get to 2 pi. So we can use unit circle to help us understand why these sine and cosine graphs look the way they do. Another thing that's important to notice is that the sine and cosine graphs basically look the same, but it's shifted, or cosine is shifted by pi over 2 radians, or 90 degrees from sine. If you were to take the sine graph and move it 90 degrees to the left, you basically will get the cosine graph. And there's a good reason for that. That's because cosine represents the complement of sine. That's why it's called cosine. It actually stands for complement. Remember, complement is when two angles add to 90 degrees. Okay. Anyway, I'll stop right there. We'll actually do the tangent in class because this video is actually getting longer than I had anticipated. So we will do the other examples. We'll talk about sine again, and then we'll see how we can make some changes to it. And then, of course, we'll talk about tangent, and you'll get a chance to do some practice in class. Okay, looks like we're all set.